Hey boys and girls, so today we're going to be going over Unit 3, Lesson 9, which is Applications of Linear Inequalities. So this is going to be taking all of the skills that we've learned so far and applying them to word problems. Before we get started, just make sure that you have your name written at the top, and let's begin. It says, Brooke goes to the movie theater and spends $13 on her ticket. Each snack at the concession stand costs $2.50. If she goes to the theater with $20, write an inequality that represents the maximum number of snacks that Brooke can buy. And then it has a hint. It says we should begin with a let statement. All right, so before I get to the let statement, I want to just cube this question. So I want to circle my key numbers, box my math action words, and then at the end I want to underline the question so I make sure I answer it completely. So as I look at the first sentence, Brooke goes to the movie theater and she spends $13 on her ticket. So I'm going to circle 13 because I know that represents the amount of money for a ticket. Each snack, each I know is a multiplication word. So since it's telling me what to do, I'm going to box it, and then I'm going to put parentheses up top to remind me that I'm going to multiply. So it says each snack at the concession stand costs $2.50. All right, I'm going to circle 250. Again, that's a key number. It says if she goes to the theater with $20, so she's got $20 in her pocket, here's the question. This is what I want to underline. It says write an inequality. Be really careful, not an equation, an inequality that represents the maximum number of snacks that Brooke can buy. All right, so when I answer the question, I'm going to say Brooke can buy 10 snacks, right? She could buy 15 snacks. That's the goal of the question. How many snacks can she buy? All right, on the side, again, we're going to set up a let statement here. So x equals, well, if I read the question, it says I want to represent the maximum number of snacks. So that's what x will represent in this question, the number of snacks that Brooke can buy. All right, because that's what I don't know. So that's what I'm going to let x represent. So now if I go back, I know that every equation or every inequality pretty much looks the same. I always have a bunch of information on the left-hand side. I have my equals or my inequality in the middle, and then I have my total at the end. So again, this is all of my information from the question. This is where my inequality is going to go. And then at the end, I always have my total. All right, so as I read the question here, I'm going to just start out with that total number. How much money does she have? Well, she's going to the theater with $20. So I know she's got 20 bucks in her pocket. I can fill that in. Then I'm going to actually move to the inequality, because as I'm reading this question, I don't see any keywords that tell me if this should be a less than, a greater than or equal to. So what inequality should I pick? Well, if Brooke has $20 in her pocket, that means she can spend up to $20. It's going to be an equal, all right? But now I have to decide, is this going to be less than or equal to, or greater than or equal to? Well, if she only has 20 bucks, she can't spend more than 20, but she could spend less than 20. So she could spend less than or equal to $20. So I've used the 20. All right, so now I got to look back, and the only numbers I have left are the 250 and the 13. Brooke goes to the theater. She spends $13 on a ticket. 13 is going to be a one-time fee. That number will not be multiplied with any variables. All right, so I'm just going to keep it by itself. And then it says each snack. Again, each is a multiplication word. So each snack, well, if you look at our let statement, we're letting snacks be represented by the variable x. So I'm going to say each snack, the number of snacks is x, okay, is represented by that number $2.50. So I'm going to multiply x and 250. So again, that gives me 250x. All right, and now I have to decide, what am I going to do with those two numbers? Well, I'm going to add them together. Because she's going to the movie, she's buying her ticket, she's buying some snacks. When I add those numbers together, I get her total, all right? So that's got to be less than or equal to 20 bucks, all right? And then I would technically be done because all it's asking me to do is write an inequality, so I do not have to solve it. So as we look at the notes down here underneath, it says creating and solving inequalities in word problems. Number one, the first thing we want to do is define the variable. That's going to be our let statement, okay? So the first step was saying that X is represented by the number of snacks. That was our let statement. Afterwards, then we want to do what we had solved before. We want to cube the question. So I want to box any keywords that I see. All right, after I box my keywords and I circle my key numbers, then I want to write out an inequality statement. Just like we did up top, we wrote out our inequality. After we write it out, then we want to solve our inequality, right? We want to solve what is X going to be represented by. And then number 5, we finally want to write out what our final answer is going to be. All right, so these are the steps that we're going to follow as we solve through these word problems today. Let's look at number 1 underneath. It says, using the inequality you created in the do now, solve to determine the maximum number of snacks Brooke can buy. So now I do want to solve, all right, that inequality from the do now so that I can figure out the maximum number of snacks that Brooke can buy. So I'm going to just rewrite our inequality. It was 13 plus 250x is less than or equal to 20. First step is to draw my train track here, and then I'm just going to start solving. X is on the left-hand side, so I have to move the 13 or the 250 first. I'm going to move the 13. 250 is hanging out with X. They're best friends, so I'm going to break them up at the end. All right, the opposite of a positive 13 is a negative. I'm going to use my inverse operation here. Inverse is the opposite, all right, to move that over. All I have left is 250x. 20 minus 13 is 7. And then last but not least, I want to get rid of that 250. So the opposite of multiplying is dividing. I'm going to divide both sides by 250. Again, this cancels. So I get x on the left, 7 divided by 250. So if I just type that into my calculator here, 7 divided by 250, I get 2.8, all right? And now I have to ask myself, did I divide by any negatives? No. So is my inequality going to change? No. It's going to stay less than or equal to. Now, the difference between what we're solving today and the questions we've been working on is that these are real life questions. When you go to the movies, all right, and you buy a snack, are you going to buy 0.8 of a bag of popcorn? No. If you ask for Milk Duds, right, a box of Skittles, something like that, are they going to give you 0.8 of that box, or are they going to give you the whole box? I mean, yeah, they're going to give you the whole box. So here I have to look at this inequality. Again, I can either be 2.8, I can equal 2.8, or it'd have to be less than 2.8, all right? So 2.8 doesn't make sense. I can't buy 2.8 snacks, so that means I want to round down. I want to be less than, so I would really only be able to buy 2 snacks. That would be the maximum number of snacks that Brooke can buy. It would have been 2. All right, so the rule that we are following right now is you're just going to ignore that decimal on the end, all right, for this question, all right? And then we're going to see what we have to do in those other word problems as we work through today. All right, let's flip and go to the next page. All right, let's look here at number 2. Connor wants to attend the town carnival. The price of admission to the carnival is $4.50, and each ride costs an additional 79 cents. Connor can spend at most 16 bucks. Part A, create an inequality to represent the maximum number of rides Connor can go on. All right, so the first thing I want to do is just go through and cube this question. All right, so I want to identify what's important. Connor wants to attend the town carnival. The price of admission is $4.50. That's a key number. I'm going to circle it. So just to get in is $4.50. Afterwards, each ride. Each is a multiplication word, so I'm going to put parentheses here. Okay, each ride. I'm going to let rides be represented by the variable R, because if I just look back at the question, try to stick with me, it's telling me that the number of rides is being represented by the variable R. Okay, so rides is R. So again, each ride costs an additional 79 cents. Additional is a key word. It tells me to add. So I'm going to add on 79 cents. That can be written as 0.79 because I'm dealing with money. So 0.79. Connor can spend at most That's a key word, at most. That's going to be represented by the less than or equal to symbol. And I'll come back to that at the end. All right, he can spend at most 16 bucks. Here's my 16. So if I want to create, or if I want to write this inequality so that the maximum number of rides is being represented by the variable R, if I look back on the first page, first step says that I want to write a let statement. So my variable here is R. R represents the maximum number of rides. So I'm going to say it's the number of rides. Now I want to go back and I want to set up what my inequality will be. So if I look here, it says I have the number 450. I want to multiply R with something. I have to add, 79 cents. There's a lot going on here. So I'm going to follow the same rules that I did on the first page. I'm going to have a bunch of information to start with. I have my inequality in the middle, and then I have my total, whatever my answer is going to equal at the end here. So I'm going to start out with my total. I know that he has $16 to spend. That's the most amount of money that he can spend. So 16 will be the total. I know that the inequality is less than or equal to because if he has 16 bucks, he can spend 16 bucks. So it can equal $16. His total can be 16. But again, he only has 16 bucks. So he can't be greater than 16. He can't be more. If anything, he would have to be less. So he can be less than or equal to 16 because that's the most he can spend. So I'm done with the 16. I'm done with at most. Now I got to go back and somehow figure out what I'm going to do with this 450 times R plus 0.79. All right, there's a lot going on here. The price of admission to the carnival is $4.50. That's going to be a one-time fee. It's not going to have any variable attached to it. All right. When you go to the carnival, you pay this amount of money to get in. That's it. You never pay it again. So I'm going to take this amount, and it says for each additional ride, for each extra ride, it's 79 cents. So I'm going to add on 79 cents for each ride. I'm going to take 79 cents, and I'm going to multiply it with the variable R. And this is the inequality that I would have gotten for part A after I combine all my key information together. Part B says solve your inequality to determine the maximum number of rides. So now I want to solve my inequality to again determine the maximum number of rides. I want to solve for R. So the first thing I want to do is rewrite my inequality, which is 450 plus 0.79R, which is less than or equal to 16. And then just like we always do, we drop our train track here and then we solve on through. R is on the left-hand side, so I'm going to get rid of 450 first because that 0.79 is hanging out with R. They're besties right now. It's going to be hard to separate them. All right, so the opposite of a positive is a negative. So I'm going to use that inverse operation to move the 450 over. This cancels. All I have left is 0.79R. 16 minus 450 is 1150. Last but not least, I want to get the variable R by itself. So instead of multiplying together, we are going to divide both sides by 0.79, divide by 0.79. This is going to cancel. All right, when we type this into our calculator, 1150 divided by 0.79. Oops, so sorry, one more time. 1150 divided by 0.79 is 14.55696. Right, there's a lot going on here. So here we go. I'm going to write down what we got so far. All right, which was R. When we typed that in, we got 14.55, right, dot, dot, dot. It was a big decimal, big ugly decimal. All right. When I look back, I did not divide by any negatives. So since I didn't use a negative, I am not going to switch my inequality. It's going to stick as less than or equal to. All right, so now I got to think here. The question says, what's the maximum number of rides? Can you go on 14 and a half rides? Absolutely not. Are you getting on half of a ride? I'm pretty sure you would die. So I have to think. Is it going to be 14.5 or should I just round down for less than and just say I'm going to go on 14? Not 14 and a half. Yeah, it's gonna just be 14 rides, so we're gonna write that out here. The answer would be 14 rides. And again, I'm getting that answer by following my inequality, all right? I wanna be less than, or I wanna equal this number, all right? Being that decimal doesn't make sense, I'd have to round down.